2x as x approaches infinity. How can you figure that out? Basically, you need to figure out what happens to 2x as x goes to infinity. As x becomes huge, as x becomes very large, what is happening to 2x? Well, anything like 2x, x squared, x cubed, powers of x, they vary directly with x, meaning if x gets big, then they also grow in the same direction. So this will also become huge, very, very large. You can think of it as plugging in infinity for x. That's not technically what's happening here, but I think it's helpful to think of that. If you put in infinity, there's some huge number for x, what would 2x be? It would also be some huge number, and we still represent that by infinity. So we put infinity for the limit. Then think about what would happen if x approached negative infinity. Well, if you put in some huge negative number for x, 2x would also be some huge negative number, and it's only getting more and more negative, becoming larger and larger in the negative direction. So this would also be huge and negative, and we would write negative infinity for the limit. Now I should quickly point out, I put equals infinity and equals negative infinity. It does not actually equal infinity. You can never reach infinity or negative infinity, but in limit language or limit speak, we write that it equals infinity or equals negative infinity because it's heading in that direction. That's what it's approaching as x goes to infinity or negative infinity. So let's look at another polynomial that's a little larger. Okay, so what if you have a larger polynomial x expression, something that starts with x squared as a leading term? Well, basically, for really large x, you don't have to worry about any lower degree terms. You only need to focus on the leading term. So you can actually just kind of ignore any other terms and focus on that. So what happens when x becomes extremely large? X squared also becomes extremely large. They grow in the same direction. So this would be equal to infinity. The limit is equal to infinity. If x instead approached negative infinity of x squared plus 2x plus 5, again, we don't care about the lower degree terms because when x is extremely large, none of those lower terms are growing anywhere near as quickly as the first leading term. So they don't make a difference overall.